Yes, sorry, there was some delay actually. It is almost like 10-15 minutes delay there, but it is fine. We will try to cover as much as possible. Um, this is the plan for 45 days that I have prepared approximately for the next coming almost 1.5 to 2 months it would be. Uh, Excluding Python. As you might be aware already, there is a Python class that will be going on parallelly after this session. So please do attend. We will have some extra time, like around another 2-3 weeks of time, so that we can cover the topics in depth. Um, Earlier, we had planned it to do it like sequentially, one after the other. First Python and then generative AI. But since trainers are available for Python, so they are doing it parallelly. That is a good thing for us as well. My main focus would be here in this area, like RAG and the AI agents, because these two are the most important and uh, in-demand skills that are required now. So we'll spend more time there, or whatever the extra time that we get, we'll spend there in case if we are not able to cover everything. So this thing you can also access it. Let me share it with you as well. Uh, this is in case if you want to go through, you can go through it. So first 3-4 days, mainly we will cover the fundamentals of ML and DL. I will try to show few of the use cases using coding also. But please do attend that Python session so that you feel more comfortable as soon as possible with the coding sessions. So today, this is what we will be covering: ML landscape and learning paradigm that we will cover. For that, let me use this X calendar. This one and yeah. So before getting into any definitions or anything, I want to give this scenario so that it will be easy for you to understand why we need machine learning in the first place. So let us say, where is this? Yeah, let us say we have some 1,000 customers data, and it is a telecom company, and we have some 1,000 customer data, and we want to understand who is going to leave this network. Basically, you might have seen, right? Like people jump from one network to other, like from Airtel to Geo and those things. That is called as churning. So, which customers are how many of them are going to churn? That is what we want to predict. Something like we need to for each month, for what would be the churning rate for the next month. So, out of this 1,000 customer, what how many customers are going to churn? Churn in the sense like move away from our services. This is what is the otherwise. Let me deal with this one. This is what is the question that we have in mind. And for this, we have this customer, 1,000 customer data. And let us say for the customers also, we have some features. Something like one is months active or inactive. And second one is something like complaints. Third one could be a bill amount. This is also one of the important factors. So these are the features for each customer that we have. So if somebody asks me, using these features for the 1,000 customers, that is the data set may look something like this. Like for each customer, we have 1,000 customers, so it is 1, 2 till 1,000 it would be. And first column serial number, let us say this is serial number, and this is months of active or inactive, and this is complaints, and this is bill amount. Data set may look like this. So we have this data set, and here now we want to predict how many uh, customers, the number of customers that are going to churn. So for this typical flow or the coding that I do, it would look something like this. Pseudocode I am writing here. For that, let me write it inside this. So if customer dot months, let us say it is inactive that we have, so that it will be more clear to you. Inactive is greater than 3. Then we will return customer churn is equal to true. Is true. Just I am writing pseudocode, so it doesn't matter syntax. So if same I will copy, but here now the feature would be something like complaints is greater than something like, let us say 5. Then return true. And another feature that we have here is same, right? Like if customer dot bill amount is something like greater than 500 or whatever, then also return true. Sorry, then usually if their bill is 0, then there are chances that uh, they will churn or they will jump from one company to other, right? That is why. So customer churn is false because they have some billing amount with them. So this is how we can write some code to predict the customers. But what if we have some 1,000 columns here, 1,000 features here? It will get more and more complex, right? And there could be some combinations also. Here we are writing very simple if condition where we are checking only one feature at a time. If months of inactive is greater than true, sorry, get greater than 3, then we are saying that customer mature. And if the complaints are greater than 5, then we are saying that customer mature. But what if this months of inactive is uh, less than some number, and greater a number of complaints are greater than some number? So these kind of combinations, conditions also we need to take care of. So once we start doing that, this logic that we are writing here manually, it will get more and more complex. It will become almost impossible to track the patterns which are causing the customer to churn, right? So that is where the machine learning comes into picture. This that we are doing here, what we are doing here, it is the traditional software development that the system can predict which customers are going to churn based on the rules that we are writing here. But how many rules that you can come up with, or how would you identify these rules? This is not humanly possible if the data is really complex. If we have, let us say, 1,000 features, 1,000 features is very common in machine learning problems. So for that 1,000 features in the sense, these things actually. Let me clarify that one also. Features are nothing but the columns. Assume now for now. Like months of active complaints and bill amount, there could be some 1,000 columns also, 1,000 features. So what if we have that 1,000 features? It is we cannot come up with these kind of manual rules that predict the customer churn. So this is software development, traditional software development. And in machine learning, we don't write rules like this. We let the system, or we let the model to come up with these kind of rules. That is what is the main difference is. So is it clear till this point? Since now you have got some idea about what is traditional software development or machine learning, let me define what is AI first. So this is, let us say, since we have multiple domains within AI, I am drawing them with circles. So this is AI, and this could be something like machine learning, and another subdomain would be deep learning, and within that we have generative AI. So the topmost circle that you see here, this is AI. So now let me give some definition for this. What is AI? AI in broader terms, we can just say that creating or making the machines that behave intelligently are just like human, that behave like human. That is AI. Again, repeating, AI is nothing but, in broader terms, we can say making AI, making machines that can think intelligently, that can behave intelligently. So let me type it here. Making machines that can think intelligently. Mm, yeah, think or behave intelligently. This is what is AI is. So in that one, like earlier also, the example that you saw here, where we are predicting the customer churn depending upon the some features or some rules. Here also it is the system or it is the machine that is predicting the customer churn, right? So we can say this is also kind of intelligent system that we have built, or low level AI that we can say. People argue about it, but still, yeah, this is also a system. It is not a human that is predicting the customer churn. Up to a certain extent, it has some intelligence. It is purely whether it is working or doesn't work. It is not up to the mark. It is up to the mark or not up to the mark. It doesn't matter for us. But at least it has some level of intelligence. So we can say this can be called as rule-based AI. This kind of stuff, it is very old, right? People are doing it from long time, like 1960s, 50s and all. So uh, this is based AI. Next thing is, when we identify that, when we got to know that it is not possible to, humanly not possible to identify all the rules that we need to come up with to predict something. Then people came up with better approaches, that is something called as machine learning. So here we have machine learning. So here what we do is, we don't we don't explicitly write rules. We let the system to come up with rules. So here basically what we do is, I think it is going beyond certain thing. Let me enter it. Yeah. So here what we do is, as shown in the earlier case, like this is the data that we had, and this will be fed to something called as model, or for now let us consider it as machine. So we will feed this data to the machine, and it will figure out what are the rules that are needed to predict this kind of customer churn. So let me write it again here somewhere. Yeah, here it will be better. So we have a system or machine or model. For this, we pass the inputs. That inputs is data. We pass the data, and what it does is basically it predicts output, predicts. In the process of this prediction, it identifies the rules for itself. I will write it here. Identifies rules itself without a human explicitly writing rules. We don't write the rules here. It will identify itself. That is the advantage. So in the earlier case, we tried to write rules ourselves to predict something, to predict customer churn. But here, the system or the model will identify itself. So here, with you can say this rule-based AI, what we used to do is, it is something like this. Let me write it here so that it will, you don't forget. We have the data, so we observe, then we think about the rules, then we write rules. Then machine follows those rules. Whether the customer is churning or not, it will predict it based on the rules that we write here. But in case of let me take it here. Yeah. In case of machine learning, we just collect the data, then machine observes itself. Machine observes, and machine will identify the rules, and then it will apply. That is what it does. So this is the difference. So hope this is clear to all of you. If you have any questions, please feel free to ask. I don't mind, but I will suggest you to enter these questions in the chat box so that I can address them at the end of the session. Since we are trying to finish it in in very fast pace, it will be better to spend a lot of most of the time in teaching concepts. But I'll make sure that I am addressing all of your questions at the end, or else I will ask to create one separate session for the doubt clarifications as well, if needed, if I am not able to address them in the debate. So next one is deep learning, the third circle that you see here. So here again, this is about ML. This is about, you can say, rule-based systems or traditional ML. That is what you need to remember. And next comes the deep learning. In deep learning, what we do is it is similar to machine learning only. Only difference is that we have something called as neural networks, which are inspired loosely from the human brain, and we use those neural networks to identify or to predict something. That is the only difference between machine learning and deep learning. But that is why this is subset of machine learning. These are very specific architecture that we follow, or the models are built based on a very specific architecture. So that is why the name deep learning, and it is subset of machine learning. And in machine learning, most of the times it is based on some algorithm. So we will discuss a few of them in the next coming sessions. Uh, so this is what it is. Deep learning is subset of machine learning where we identify or we predict something without explicitly writing the rules. Machine learning or deep learning or AI for that matter is nothing but we predict, we predict something without explicitly writing the rules. Human doesn't write the rules explicitly. System itself will observe, system itself will identify the patterns that are present in the data and come up with the rules that needs to be used to identify to predict something. That is what it is. AI or ML is all about identifying those patterns, uh, correcting itself, whether that pattern, if it is not giving correct output, we need to adjust that pattern. So it is all about identifying patterns. AI or ML, whatever. So, but the main difference between, one more main difference between machine learning and deep learning is, you might have observed here, this is something we call it as structured data, where we have the data set in the form of columns and rows. But what if we have something like text? Is columns, rows. Or what if we have an image where we have rows and columns, or each cell is represented by a pixel value, pixel index. It is also not so structured. Why I am saying that it is because of the uh, multiple reasons are why we don't call this image as structured directly, because of the three color spaces. We will discuss them in detail, but the images and audio files, these things we cannot deal this in machine learning cannot handle unstructured data formats. Most of the machine learning algorithms we cannot deal with image unstructured data. So that is why neural networks or deep learning is very important for unstructured data set. And yeah, one more issue with the deep learning is that we need huge amounts of data to train neural networks. Neural networks are data hungry models. If you have some 500 data points also, you will be able to train a machine learning model. But you cannot train neural network. You need huge computational power for that. So neural networks are data hungry models. We need huge data and huge compute. So the computing power that is required, that is the GPUs. GPUs are computing power is becoming more and more cheaper day by day. So that made them to what to say, become so famous, because earlier the GPU cost or the computing cost was not so less, or it was not cheaper. So they didn't come into the limelight. But since this GPUs or the computing cost started becoming more and more cheaper, these deep learning techniques or the deep learning architecture started becoming they started seeing the real-time usage basically. So let me repeat again. AI is nothing but making the machines, creating intelligent machines, we can say, making the machines that behave or think like, intelligently. And machine learning is nothing but we don't without explicitly writing the rules to predict something. We let the system to decide the rules, to identify the patterns, we let the system to come up with its own rules to predict something. That is what is machine learning is about. And in deep learning, we do the same thing. We predict something, but only difference is that the underlying principle, underlying architecture that we use, it is completely different from the machine learning. In machine learning, most of them times we use algorithms. We have different machine learning algorithms to predict. But in deep learning, we use architectures, neural network architectures. That is the main difference. And machine learning cannot handle structured data machine learning can handle structured data only. But in deep learning, we deal with both structured and unstructured data sets, data types. That is the another difference. And if you have very small data samples like 100 or 200 also, you will be able to build a machine learning model. What is model? I'll talk about it later. But if you have only 100 data points, you cannot build a neural network. Basically, what happens there is it happens overfitting, we say. It tries to by heart all the 100 data points. That's all. So there won't be any learning that is happening. That is why deep learning models are data hungry models. You need huge data as well as the computing power to build deep learning models or the neural networks. So again, repeating, machine learning, we deal with structured data. And if you have very less samples also, it is okay. You can build a machine learning model. And underlying principle is we use some algorithms, statistical algorithms, or many times even some algorithms to come up with the prediction. But in deep learning, we use neural network architectures. They are data hungry models, and we need huge data and compute to come up with the prediction or to build the model. And machine learning models cannot work or don't work with the unstructured data. They need this kind of structured data where we have the data in the form of columns and rows. But deep learning, it can handle unstructured data as well, like audio, images, and even videos also, video files as well. Hope this was clear. And what about the generative AI? Sorry, I had missed this one, the final part, the innermost circle, Gen AI. Here in deep learning or machine learning, what happens is we predict. That is, we have some input, something like this, and we predict. That is what we do. But in generative AI, if you see in ChatGPT or Cloud, you can you can generate something. There in machine learning and deep learning, we don't generate new content. We don't generate new text. We don't generate new images. But in generative AI, we can do that as well. So that is the main difference. But again, how does it learn? Underlying architecture, it also uses the deep learning architectures. That is why you see generative AI is subset of deep learning. So very specific architectures like transformers it uses to generate the content. So this is about this generative AI. Now let me explain how does the machine learn? How do they come up with these kind of rules, or basically how do they learn the patterns that are present in the data? With some example. Let us say uh, I have a data set which looks something like this: x, x1, and x2, and x1 is 1 and it is 2, and output variable I am call it as y, let us say, and this is 5. When x1 is 1 and x2 is 2, then output is 5. And when x1 is 2 and x2 is 4, output is 10. And when x1 is 7 and x2 is 2, output is 11. So can you think what would be the output for, let us say it is 10 and it is 1, and what would be the output? This is what is, it is a typical machine learning problem, right? Where we have input features, x1 and x2, and output y. So when x1 is 1 and x2 is 2, output is 5. And when x1 is 2 and x2 is 4, output is 10. I'm just verifying one more time. When x1 is 7 and x2 is 2, yeah, 11, correct. So can you try to think of what would be the output for this one? In that process, unknowingly, you will think of what would be the pattern that this guy might have followed, right? That pattern is nothing but the rule. So if you don't, that is the abstract way of thinking it actually. We humans, we think this, I'm little bit deviating, but it is important to know. Humans have this abstractive thinking where we don't think in terms of what to say, rules or something. It is something depending upon the patterns. So here, the pattern that I want you to observe is, it is something like x1 plus 2 times of x2 is equal to y. This is the equation, or this is the rule or the pattern that I followed. X1 is 2 and x2 is 4. 4 into 2, 8. So this is the pattern that, or the rule that it creates. Sorry, the using which I have created this output variable. So in machine learning terminology or AI ML terminology, we call this one as model. Model is something that predicts outputs. That's all. So here, for a given x1 and x2, it predicts y. That is, it is a model. So this model contains two parameters. One is this thing and this one. This one is nothing but 1 and this one is 2. These are coefficients. This we call it as parameters in machine learning terminology. Params. So model is something that predicts output, and it predicts output through parameters. This is this you can relate it with the size of the models as well, that you see, like initially for example, llama is an LLM from Facebook. So they came up with 7 billion parameter model. That means that these kind of parameters, they had 7 billions. And recently, I think GPT 2 point some version or 3 version, it had some 125 billion parameters. It means that these kind of parameters, they had 125 billions. So as the number of parameters gets bigger and bigger, model will have more and more capability to learn. Why I am saying this? Because here we are operating in two dimensions. If you add one more dimension to it, it will be able to capture another dimensional pattern also. Likewise, if it had some 100 dimensions, then it will be able to capture much more. It is not only 100, to be honest, like it would be a combination, a combinational thing also. So the more the number of parameters, more capability that the model has to learn. It can learn complex patterns also, more complex patterns also. But we will discuss that later. But for now, you need to understand what is model is. Model is something that can predict the output for a given input. Here the model is x1 plus x2. That is what is the model is for this use case. And what are these 1 and 2 that I came up with as patterns or as my observations is those are parameters. This model will learn during the training, we call it as. So these parameters are the ones that makes or that model consists of. These parameters model has to learn. Indirectly, it has to learn the rules. Indirectly, it has to learn the pattern that is present in the data. This is what is pattern, right? First, I need to take x1 and then multiply it with 2 and add it together. That is the pattern that is present in the data to predict this y. That is the rule that this data set is following to for the output production. So params are nothing but are the parameters represent the rules, represent the pattern that is present in the data. So those parameters are important things. Model tries to learn those parameters during the training. We don't create these parameters. Model will create. Model will create these parameters during the training. Model learns the parameters, we can say. Model. So if model is learning the parameters, it means that model is learning the rules. Model is learning the patterns. How does it learn? I will explain later. But now the important terminology again is model and parameters. So model is nothing but it has to predict the output for a given input. For a given set of input parameters to make it perfect. So it predicts the output for a given set of input parameters. And what are these parameters? Parameters are the ones that that model uses to predict the output. And these parameters are learned during the training. If I say that the model is learning parameters, I am saying that it is learning the rules. It is learning the patterns that are present in the data. So these 3-4 points are very, very important. You will hear this again and again in AIML. Model, parameters, training, these terms are important. Terminals. I hope I made it clear about this model. And the next thing is about the training or learning. How does the machine learns in the first place? How does this model or system can come up with these kind of parameters? 1 and 2. So learning paradigm or learning. So let us take the same example 1, 2, 5, 2, 4, 10. 7 to 11. It would be 12. Right. So here, let us say what we'll do usually is those parameters. I will start with very random numbers. Let us say I started with 0 and 1. That is x1's parameter. Like this is x1 and this is x2 and this is y. So x1's coefficient is 0 and x2's coefficient is 1. Then what is the output that I will get here? As output 0 and 2 multiplied by 1, 2. So output I would get is 2. So what I will do is, since it is less than 5, I will try to increase any of these parameters. Again, I am repeating, that is something like the equation that I want to come up with is ax1 plus bx2, something like this. Here, I am just starting randomly. It can be 0, 100, or it can be 100, 100. It can be 1,000, 2,000, anything it can be. But for now, I just started with 0 and 1 for A and B. So since I started with the 0 and 1, the output that my model, this model that predicts is 2, but the original value it is 5. Again, it can be called as original value or ground truth, we call it as. It is coming from the data set. Ground truth is nothing but the reality or the real value. This is nothing but the predicted value. A terminology you need to know, or you should get habituated of this terminology. Till now, what we have seen, model and parameters. What is model? Model is nothing but it takes some input parameters and then predicts output. It has to predict the output for a given set of input parameters. That is model. And what are the parameters? Parameters are the values through which model tries to predict the value. These parameters are learned during the training. These parameters model tries to learn during the training. Those represent the rules or the patterns that are present in the data. Those parameters represent the rules or the patterns that are present in the data. And next comes this x1 and x2 and y. X1 and x2 are called as input features. Why? Because these are the ones that we are using as input to predict the y. So input features are just features. These are interchangeable terminology people use. So x1 and x2 are input features and y is output feature. Or x1 and x2 sometimes they call it as input variables and y is output variable or target. So let me write it here so that it will be clear to you again. Input, inputs, input features or input variables. All of them are same, or even features also, just features. All of them are nothing but this x1, x2 we are referring to. And output, target, output variable, all of them are referring to this y. And both of them together, we call it as ground truth. For ground truth, x1 and x2, y is the prediction, y is the output. So this is one thing. Next, yeah. So once we have this, we decided that this is the a value as 0 and b value as 1, and then predict value for input of 1 and 2. Then output that we are getting is 2. Since it is less than the actual value or the ground truth value, then what I will do is I will increase it by some value, A or B, anything it can be. So let us say I have increased this one, x1 by 1 value. That is, I am just doing plus 1 here. So that will be 1 and this will be 1. Let me make it more explicit by writing these values here so that you don't get confused. It is 0 multiplied by 1 and 1 is the parameter and 1 multiplied by 2. So 0 into 1, 0, 1 into 2, 2, that is by 2. And here in similar way, x1 is nothing but 1 and this is nothing but 2. So now the output that I would be getting is 3. Still it is less than 5. So since I had already increased this by 1, this time I will try to increase it by, I will try to increase the second parameter by 1. It is up to you. So now it would be 1. This is 2. So 2 into 2, 4 plus 1, 5. Now it is matching. So here we started with some random value and we adjusted these parameters to identify how far this output prediction is from the original prediction or original ground truth value. And then we move towards it. Let us say here, rather than increasing this by 2, let us say I had increased it to 20. Then the output would have become 41, right? 41 is much, much higher than 5. So in the next step, what I would have done is I would have decreased it in the similar way. I would have made it 2 because it is too far. I am not reducing it in the increments of 1 or 2. I am reducing it in the increments of 10 itself so that I can converge faster. Converge in the sense I can reach the ground truth value as soon as possible. That we will discuss. That is a learning rate, we call it as. Again, yeah. So here, since our prediction is not matching exactly, we try to adjust these parameters and then reach the ground truth value. Here in this case, it would have been 21. Still, it is less higher than the value. So I will still reduce it. Maybe I will make it 5. So 5 into 2, 10, 10 plus 1, 11. 11. Still, it is less. So likewise, we proceed. And since computers, they don't like, it is not boring for them, they can repeat these kind of steps millions of times, billions of times. They can start with any random value and adjust these parameters values to get the exact output value. And now you can ask me, what if this is working for this data point, but it may or may not work for the next data point. But since systems can do it like repetitively without getting frustrated or without getting bored, they can repeat it and reach the optimal value. And how do they do it? With this, humans have designed it. Of course, we'll discuss that. There are better approaches or the optimized approaches that systems follow. But ultimately, this is the high level, very high level explanation for how does the machine learn. Machine starts with these kind of random values and then adjust its parameters and compares the output with the original value or the ground truth value. It will check how far it is from the original value. This prediction 3 is how far from it. Depending upon that, it decides about the next adjustment. If it is really far away from the ground truth, then the adjustment also will be huge. If it is really close to the ground truth, then adjustment it makes is it will be smaller. That is how machines learn. That is how they identify the patterns. It is not. It is in very indirect way of identifying patterns. But yeah. So this is about learning. How does the machine learn? So let me just repeat once what we have done today and then conclude this. So first we started with the what to say, why do we need machine learning in the first place? And what is software traditional software development looks like for the customer churn use case. So we had some thousand customer data points, and then we tried to predict churning customers who are going to move away from our company using some 3 parameters. So then we discussed that what if we have some thousands of features and this kind of rules human has to come up with himself or herself. It will be almost impossible to come up with this kind of rules that can predict the customer churn. So this is impossible. That is why we have machine learning or AI. And this can also be called as rule-based AI. Since here, what is AI? AI is nothing but creating machines that can think or behave intelligently. So this is also an intelligent system, but low level, right? So here, rather than writing the rules, we let the system to come up with this kind of rules. We let the system to identify this kind of patterns. Pattern is nothing but if bill amount is some positive value is there, customer is not going to churn. That is what is our assumption. So system will learn itself these kind of rules are the patterns. So and next comes the ML part. Yeah, already I talked about. And ML is nothing but here again, like we teach the machine, we train the machine to learn some patterns from the data that it sees without explicitly writing the rules. We let the machines to learn the rules themselves. And here, uh, next is deep learning. In deep learning also, we do the same thing. We predict the output without writing the rules explicitly, but using a special type of architecture, underlying architecture called neural networks. In machine learning, we use algorithms most of the times, like linear regression, logistic regression, decision trees, clustering. These are the algorithms. And they can work only with the structured data. They cannot deal with the unstructured data. In deep learning, we deal with the unstructured data as well. And deep learning models are data hungry models. They need huge amount of data to train a model. And we for that, obviously, we need the huge computation also. That is the next one. And next, we discussed about the few of the terminologies that we use. That is model and the parameters. Model is something, it takes the inputs and predicts the output. For a given set of input parameters, what is the output? That is what model does actually. In case of machine learning and deep learning, actually, in generative AI, where we generate the new content, output is something, it will generate the content. That is the difference. We'll discuss it. Anyway, we are going to discuss about the generative AI throughout this course, but this terminology is important. So model is nothing but we, for a given set of parameters, input parameters, we predict the output, and parameters are the ones that represent the patterns, that represent the rules that are present in the data. These are learned during the training. That word learned, parameters are learned during the training. That word is very important. Okay, we don't create, we don't give it as input. Model learns itself. How does it learn? By this kind of mechanism that I explained. This is very simplistic mechanism that I explained, but intuition, you can say very basic intuition. It starts with some random values. It adjusts these values according to one rule, that is something, how far it is away from the ground truth, how far it is away from the actual value, how far its prediction is away from the actual value. Depending upon that, it adjusts its parameters so that it reaches this point after some iterations. It can be 100, it can be 200, but it does this kind of iterations. I hope it is clear. So next we will discuss few more terminology on machine learning and then we'll continue. Any questions we have? I'll stop it. I am not able to see the chart actually. Yeah.
Hi, Nageshwar. As you told that we have the continuous session after this for Python, right?
Yes. Not
Okay.
continuation. There would be some break in between. After that, we will have Python.
Okay. Yeah. Is that the link which you shared for the Python?
Mm, Sorry, your voice is not audible.
Is that the link which you shared in the beginning of this meeting for Python?
No, no. This is this syllabus link. The link that I shared. This is this
Oh,
one. Day by day plan one. It is this one. I think meeting link. Yeah. You can get it from coordinators. I'll ask them to share it with you.
yeah, sure. Thank
Yeah.
you, Nageshwar.
Uh, Anything else? You will get the link, Karthik. I will ask them to share it.
Sure.
Yeah. Okay. Anybody else has any other questions? Okay. If no questions, then we will stop it here. Thank you. Thank you all. Have a nice day.